So for this lesson, we will use properties of exponents that we learned from 5.1 from a few days ago to simplify rational exponents. And so like the last section, we talked about how rational exponents are just exponents that have a fraction in them. They can be converted to radicals. So just to recall from the last lesson, remember that the square root of x is the same thing as saying x to the 1/2 power. And so the way that we write the square root of x, we call that radical notation. And the way that we write x to the 1/2, we call that exponential notation. So just a few things to remember from the last section. So number one, we have x to the 1/3 times x to the 1/2. Since they are on the same horizontal plane, it's not a power raised to a power, they are even with each other. I take the exponents and I add them together. So I will add these exponents. So I would take 1/3 plus 1/2. In this case, we need to find a common denominator, which could be 6. So I could write 1/3 as 2/6 and 1/2 as 3/6. And you end up getting 5/6. So if I were to put this in exponential notation, it would be x to the 5/6 power. Or if it asks me to do this in radical notation, it would be the 6th root of x to the 5th power. For number 2, we have a power raised to a power, like this. So when you do that, when you have that, you would like to multiply your exponents. So 15 times 1/5, 15 divided by 5 would give me x to the 3rd power. That would be my final answer. Here we have an exponent that is on the outside of a parenthesis. So I want to distribute this exponent to all of my terms. 16 to the 1/2 power would be the same thing as saying the square root of 16. I would take 8 times 1/2, so x to the 4th power. And 10 times 1/2 would give me y to the 5th. And so if I want to simplify this one step further, I would write this as 4, x to the 4th, y to the 5th. For number 4, here I have a negative exponent. So I have the square root. I have 25 to the negative 1/2. This would be the same thing as saying 1 over 25 to the 1/2. Remember, because if you have a negative exponent, you drop it to the denominator, it becomes positive. And 25 to the 1/2 is the same thing as saying the square root of 5. And so the square root of 25. And so the square root of 25 is just 5. So the final answer would be 1/5. Here we have x to the 2/3 over x to the 1/6. Remember that if they are in fraction form or irrational, then you would just subtract the exponents. And so if I am subtracting the exponents, again, I need to get a common denominator. So I'm going to switch this to 4 over 6. 2/3 is the same thing as 4 over 6. So I would take 4/6 minus 1/6, which gives me 3 over 6. And so the larger exponent is on top. So then my final answer would be x to the 3/6 power. I can reduce that fraction to be 1/2. So this would be in exponential notation, but if I wanted to put it in radical notation, I could also say the square root of x. Either way. Number 7, I'm going to distribute this 1/3 to the top and to the bottom. And so power raised to a power, 6 times 1/3 gives me x squared. And then on the denominator, I would have 125 to the 1/3. And y, a -3 times a 1/3 would give me a -1. Now I'm going to take this negative exponent and bring it to the top. So that would give me x squared y to the first, or you could just say y, over 125 to the 1/3. Well, 125 to the 1/3 is the same thing as saying the cube root of 125. And so the cube root of 125 is just 5. So my final answer would be x squared y over 5. Here are some properties of radicals, and so you may need these if you need to split up radicals. If you have two terms that are underneath a radical, you can split these up, so you can split them. The same with a rational. If you have a quotient that is inside a radical, you can split them up as well. So you're able to distribute that square root or whatever root that is, any radical. Okay, so here and now I want to solve. I want to solve for x. And so if I want to solve for x, my first step is I need to subtract 13 on each side. And I get x to the 2/3 equals a +4. Now, if you're wanting to get x, this exponent, to equal a +1, then you raise each side to the reciprocal. Not the negative reciprocal, just the same sign, but the reciprocal. So on the left side, the reciprocal of 2/3 would be 3/2. Here we have 3/2. And so that will cancel on the left, and you get x equals 4 to the 3/2. However, I don't want to leave it like that. I still need to simplify. So 4 to the 3/2 is the same thing as saying the square root of 4 cubed. So the square root of 4 is equal to 2, and 2 cubed is equal to 8. So my final answer would be 8. Then you could go back and check that if you wanted, just to be sure. Okay, here we have 3x to the 3/2 over 375. So my first step in solving this is I want to divide each side by 3. And you get x to the 3/2 equals 125. So isolate the rational. Now I want to raise each side to the reciprocal. Reciprocal of 3/2 is 2/3. 2/3. So I get x equals 125 to the 2/3. That is the same thing as saying the cube root of 125 squared. The cube root of 125 is 5, and 5 squared is equal to 25. Again, you could put this in your calculator if you needed to, but some of these you're able to do in your head. Number 10, I want to get x by itself, so I divide each side by -2. and you have x to the 3/4 power is equal to a positive 8. Then I would multiply each side by the reciprocal. 4/3, 4/3. So x is equal to 8 to the 4/3 power. That is the same thing as saying the cube root of 8 to the 4th power, which would be 2 to the 4th. And 2 to the 4th power is 16. So your final answer is 16. Number 12, I want to get rid of the negative 2/3 first. You can either divide by 2/3 or you can multiply by negative 3/2. So that will cancel the negative 2/3. And I have x to the 1/5 power is equal to negative 2 times negative 3 over 2 is equal to 3. Then I have x to the 1/5 power is equal to 3. I'm going to multiply or raise each side to the reciprocal, which would be 5/1, or to the 5th power. Either way, you can write it either way. That will cancel. And you get x equals 3 to the 5th power. You may need your calculator to do this, but you end up getting 243. If you didn't have a calculator, then you would have to do 3 times 3 times 3 times 3 times 3. And I can definitely do this in my head. This part, you get 81 times 3, which gets you 243. But I probably would not be that evil on a non-calculator part. I maybe could, but I don't think I would do that to you. Okay, lastly, or second to last, we have this stuff in parentheses raised to the 4/3 power. I want to get rid of this exponent first, so I raise each side to the 3/4. 3/4. And you get x minus 4 equals 81 to the 3/4 power. That is like saying the 4th root of 81 cubed. The 4th root of 81 is 3 cubed, and 3 cubed is 27. So x minus 4 equals 27. I still want to solve for x though, so I need to add 4 on each side, and you end up getting x equals 31. Okay, last one. Same thing as I did on number 12. I'm going to raise each side to the reciprocal, so 3/2. Nope, I'm not going to do that. I forgot, I did not see this plus 3 right here. Getting old. Okay, so I need to subtract 3 first. What am I thinking? X plus 2 to the 2/3 equals 7 minus 3, which is 4. Now I want to raise each side to the 3/2. So when I raise the left side to the 3/2, that will cancel, and I get x plus 2 equals 4 to the 3/2. That is the same thing as saying the square root of 4 cubed. The square root of 4 is 2 cubed. That gives me 8. So x plus 2 equals 8. Then I want to subtract 2 on each side. So x equals 6 is my final answer.